Hi data scientists, welcome back to Breath of Data Science. I'm Tarun. I have a master's in data science and I am currently working as a data scientist in Germany. I have created this channel to share my knowledge of data science, programming and related things. In my last video, I talked about data preprocessing in Python for machine learning. I covered topics like how or what libraries to import, importing your data sets, how you can handle missing data in your data set, how you can handle categorical data in your data set, how to split the data set into training and test sets, and how to do feature scaling. If you haven't checked out that video, I highly recommend that you check out that video to understand some aspects of data preprocessing, and then we can move on towards today's video. In today's video, I will show you how you can implement simple linear regression in Python with a simple machine learning model and a simplified explanation. So today's video will cover the 7 topics or the points that you see on your screen. We'll import the libraries that are needed. We'll import the data set. We'll split the data set into training and test set, fit the simple linear regression model onto the training set. Then we'll see how the prediction on the test set results to be, and then we'll visualize both our training set results and the test set results. So simple linear regression is just a statistical method to find relationship between two continuous variables. And out of the two variables present, one is an independent variable and the other is a dependent variable. So for example, relationship between height and weight. And as I've said that this is a statistical relationship, this relationship is best defined by the famous line equation that you see on your screen right now, y equal to b0 plus b1 into x, where y is your y is your dependent variable, x is the independent variable, and b0 is your base value of the relationship, and b1 is the slope of the line, explaining the relationship between y and x. So for instance, let's say talk about salary and experience, how they go in line with each other. Here on the graph that you see, or on the plot that you see, y refers to how does a person's salary change with the years of experience that the person has. So in that case, salary should be dependent variable and the experience will be the independent variable. And the base value will be the salary of a person who has no experience. So this point here will be your base salary, B0. And in our code example, we are also going to work on such a data set itself. And in order to determine what is the best fitting line, we'll do the regression model where we see how the predicted value differs from the actual value by taking the sum of difference and squared, and we try to minimize that value as much as possible. So now let's first import the libraries that are needed and then do the pre-processing steps and see what the data set looks like, and then we'll move forward. So in NumPy we use for any numerical related procedures, matplotlib.pyplot for plotting, pandas to handle our data set and to look at our data set, and scikit-learn.linear model contains the linear regression model that we will fit our data on. I'm also using an additional library here called detail. So this library is nothing but a better way to look at your pandas data frames. So I'll show you what I mean by that. So let's import the libraries and then let's import our data set. So here you can see we have, let's look at the entire data set first to understand what does the data set looks like. So I am going to use the detail library, as I told you, to have a better representation of the data set. So it gives you a pretty demonstration of what your data frame looks like. So here in this data set, we have 2 columns because we are working on simple linear regression, one independent variable and one dependent variable. So our years of experience is the independent variable and salary is the dependent variable. And we have about 30 rows in the data set, and we have split the data set into the independent and dependent part by taking the first column and the last column into X and Y. So you can have a look at them individually as well. So you see your years of experience as your independent variable into X, and your salary as a dependent variable into Y. So now what we'll do is we'll split our data set into training set and test set. So you can use the scikit-learn model selection train test split to split your data set into whatever ratio you want. So I'm using test size to be 1/3 of the entire data set. And if I run this code, it will split my test and train data set, data set into test and train. And we can check by checking the length of our data set. So if you remember, we have about 30 rows here, and in our X train now we only have 20 rows because we divided the training and test sets into 1/3 as you see here. So now to fit simple linear regression onto the training set, what we need to do is we need to call the linear regression method or the class that we pulled from scikit-learn linear model above here. And then we call regressor.fit and pass in our X train and Y train. So to understand what the regressor does, let's go and look at the figure again. So what happens is we have all these data points that you see in your plus here. Those are your actual data points. And then what the model does is it tries to predict these values B0 and B1 and tries to draw a line so that you can plot the entire points, actual points on this line, because that is what we want to do to predict for the unseen values. So sometimes what will happen is these values will not exactly fall on this line. They'll have some difference like you see on this curve as well. Some will be below the line, some will be above the line. And then to ensure how to update the values of B0 and B1, what needs to be done is you take the actual value of the data point here and then the predicted value, and then you do the difference, square it, and then sum it, and you try to minimize it as much as possible. So this is called sum of squared errors. So we try to minimize it, and this is how the linear regression model works. And as when we call the regressor.fit method, this is what this method does. Now what we'll do is we'll see what does the prediction looks like on the test set. And we can call the predict method on the regressor object of the linear regression class and pass in our X test. And we have the predictions from the regression model into y_pred. So now what we want to do is we want to see how does the results look like for both the training set and the test set. So first we'll visualize the result of the training set. So here you see the red points, those are your actual data points, and the blue line is your regression line received from the regressor model. And when you plot it, you see that okay, it does not exactly fall on these data points, but it's pretty close to the data points as well. There are only a couple of data points that are pretty far from the line. And when you do the same for test set, you see that okay, it does better than the training set, because we have less data points here, and the other being that the regressor model fit well on this data points, and you can see it does not differ too much. Here you can see that 5 out of 10 data points lie on the line itself, and 3 out of 10 are very near to the line, and only 2 out of 10 points are a little bit farther. So this concludes my post on simple linear regression in Python for machine learning modeling. I hope you understood what I was trying to convey, and if you have any questions, just feel free to ask them in the comment section, and I'll be more than happy to reach out to you.